am going live right now. I want to get, I already have a couple videos on how to do probability, the performance final. So I'm just going to go over the first page of this. Let's take a look. So the first question says, write an equation of a circle that's centered here with a radius of 5. So I'm pretty sure it's graphed already on your test, but if not, you can just graph it -2 down to -5. Here's my center. The radius of 5, I can count up 5 over 5, down 5 over 5, and then you can kind of go beep, 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 circle. Remember, anytime that you go from the center to the formula or vice versa, we switch the signs. So here I'm just going to write x instead of -2. This has to be a +2 squared plus y. This becomes a +5 squared. And then anytime that you go from the radius to the formula, we know that we square it. So 5 squared is 25. That's like literally number 1. Now, all of these go together, so don't get confused by these numbers. Now it wants to know, determine if the point is inside, outside, or on the circle. When you do this, you're going to use the distance formula. Now, I'm going to use the earache hack on this because that's way easier for me. The earache hack is you put 1 point. You're always going to have the center on top. So we're going to put the center. Well, you don't have to have the center on top, but I just like doing it that way. So we know we're going to do this 3 times. Whoops, I wrote the number 3. Okay, and then you put the point underneath it. So this is for A. I'm going to put down -4, -1. For B, I'm going to put down +1, -1. And for C, I'm going to put down 0, 0. So I'm doing all 3 problems at once. You put one on top of the other. Then you're going to have to draw your subtraction sign. So each of these things, that whole thing gets subtracted. And because the whole thing gets subtracted, we have to change all the signs. Change, 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 change. All the signs get changed. Then you just add straight down. -2 plus 4 is +2. -5 plus 1 is -4. And then I'm just going to keep doing the same pattern. -2 plus, or we made that -1 is -3. -5 plus 1 is -4. -2 and 0 is -5. And -2, -5. Then after you add them all, you're going to square each one of these ideas. And then we add them up. So we've got 4 plus 16. That gives me 20. 25 is my target. So this is going to be inside. -3 squared is 9. -4 squared is 16. Added up, I get 25. That's my target number up here. So I know this is on. Here I have 4. Here I have 25. So I get 29. So this is outside. And that's literally the end of that problem. What? Then it wants an equation of the line that is tangent to the circle at the point -6, -2. So first things first, for tangents, we need to find the slope between the point and the center. So we know slope is y2 minus y1 divided by x2 minus x1. So here I've got my 2 points. Again, the center was -2, -5. And my point that they're asking me about is -6, -2. So I'm going to try to keep it color coded for you. So I'm going to do -2 minus -5. So I did this first. Then I'm going to do -6 minus -2. And that's all divided by. So now I'm going to just do the math. This becomes 2 negatives in a row. Becomes positives. 2 negatives in a row becomes positive. So I've got -2 plus 5 is +3. -6 plus 2 is -4. But that's not proper math. So we have to flip that slope to be -4/3. So all I did is I plugged these numbers into this equation. and got negative 4/3. That's my first slope. But now we need to take the perpendicular. Whenever we do perpendicular, we do the opposite and then we do the reciprocal. So negative 4/3, the perpendicular to negative 4/3 is ooh. Whoa, 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 whoa. Don't listen to me. I already flipped it. That's why. I was wrong. Let me change this when I rewrote it. So the negative goes on the top. So I have negative 3/4 here. 4. So I have negative 3/4. I've just done this problem so much. Sorry, that's what happened. All I did was move the negative to the top. Oops. I'm going to put oops. Jed's face. Growth mindset, we're okay. Here we have to flip it. So negative becomes positive. The 4 goes on the top and the 3 goes on the bottom. So 4/3 is my perpendicular slope. But we're not done yet. Now we're going to write y equals mxb 2 times. Y equals mx plus b. And then this is where we're going to get our answer. Y equals mx plus b. So for our answer, we're going to keep the y and we're going to keep the x. Now we just discovered that 4/3 was our b. So we're going to throw, 4/3 was our m. So we're going to throw 4/3 into the slope. What we need to do now, I apologize if you guys are writing comments. I can't see them right now. Now we're going to take our point and our slope and we're going to throw it into this equation. So my point was -2, -6, -2. So I'm going to put a -2 in for y. I'm going to put my slope in. And then I'm going to put in my x. And I'm going to put -6/1. And we know that's plus b. So now you're going to do the math. Well, you could do this on the calculator. 6 times -4 is -24 divided by 3 is -8. Add 8 to both sides. That should be add 8. So when we do that, these cancel. We're left with 6 equals b. So over here, we're just going to put plus 6. And this is our answer. So all of that work explains the reasoning. First thing we did was find slope. Then we took the reciprocal, opposite reciprocal. Then we plugged that into y equals mx plus b. We wrote it twice. The first time we used it to find our b value. The second time we used it for our answer. Okay, last couple questions on this side. The quadrilateral is inscribed in the circle with the vertices such and such, such and such. Prove it's a square. Well, this is a long problem. I recommend by doing slope 4 times. We're actually going to do slope 6 times. And basically, this is what we're doing. Here's our square. Doesn't matter how you label it. Just make sure it goes in order around the circle, PQRS. So in order for it to be a square, we have to prove that the adjacent sides or consecutive sides are perpendicular. So we would have to figure out PQ, QR, RS, and SP. We also need to know that the diagonals are perpendicular. So we would also need to know PR, and we need to know QS. And that only tells us if it's a rhombus, or no, that would be enough. So that's all we have to do is that. In theory, you would also want to make sure that the diagonals bisect each other. But really, we can just skip that. So pretty much we're just doing distance formula 6 times and comparing. So let's draw a line here. So first, we're going to compare these to see if they're perpendicular. P, I'm going to do, all we're doing is slope. So slope is y2 minus y1 divided by x2 minus x1. You also could do You also could do y1 minus y2 as long as you do x1 minus x2. It doesn't matter which comes first as long as it's the same. So for PQ, I'm just going to put the first ones first. I'm going to do 0 here minus -5 here. That's divided by -2 here minus 3 here. This becomes positive. So now I get 5 over -5, which equals -1. Now I'm going to do the same thing again 6 times. Here comes QR. Now I've got Q. I'm going to get my -5 minus -10. So we know that's going to become positives. Then I've got 3 minus -2, which becomes positive. -5 plus 10 is +5. +5 divided by +5 is 1. RS, now I'm looking here to here. I'll do my S first. -10 to -5. My Y's first, rather. -10 minus -5 divided by -2 minus -7. These become positive. So I've got -5 in the numerator 2, these become positives, positive 5 in my denominator. This becomes -1. So remember, opposite reciprocal, all it means is that the flips. So -1 flips to here, that works. 1 switch to -1, that works. Now, it doesn't have to be 1 on the test. If you had 7/3 and it switched to -3/7, that's also perpendicular. It just happens here that we're getting 1 every time. Now I'm going to do SP. So I've got -5 in the numerator minus 0. Then I've got -7 minus -2. This becomes positive. So you've got -5 divided by -5, which equals 1. So now we've proven that these are all perpendicular, that they formed right angles. But we haven't proven that the diagonals bisect each other. The diagonals really do have to bisect each other. If it was a rectangle, the diagonals would be, I'm sorry, not bisect. We have to prove that the diagonals are perpendicular. If it was a rectangle, the diagonals could be congruent. But because it's a square, the diagonals have to be perpendicular. So now we're going to do PR. So we've got P here. I'm going to do 0. Why do I keep picking that color? 0 minus, so here's my 0. Now I'm going to go to R, -10 divided by this -2 over here minus this -2 here. This becomes positive, this becomes positive. So I'm left with 10 over 0, which technically is undefined, but for our purposes, all that means is the line is going straight up and down. Now we're going to look at QS. QS, let's do some green. Q, we have -5 minus -5 right here. And then we've got 3 minus -7. These become positives. So after 0 over 10. So that means our slope ends up being 0, which goes this way. So we have proven that it is a square. Okay. And you could please write something that like, because all sides are perpendicular, all consecutive sides are perpendicular. And because the diagonals are blah, 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 diagonals are perpendicular, then it's a square. Why did I draw a rectangle? I don't know. There's a square. All right. Find the area and perimeter of the square is part 4. Show all the work. Basically, the good news is it's a square. So you only have to find the, all the sides are the same. So really, we only have to find the distance between 2 points. So I'm going to do PQ because why not? I'm going to use the ERIC. So I'm going to put P on top, Q on the bottom. We know that we're subtracting. So I'm going to do change, change, change. We add going down. This gives us 25 plus 25, which equals 50. And we have to take the square root of that. You can do it as a decimal. You also could break the square root of 50 up to 2 square roots of, 5 square roots of 2. So you could also break it up into 2 and 25 and do 5 square roots of 2. So now if we know that this is 5 square roots of 2 and we have that 4 times, it's just be the same thing as saying like 5x plus 5x plus 5x plus 5x. And so in this case, it'd be 5 plus 5 plus 5 plus 5, which is 20, and then our square root of 2. You probably will end up doing it in a calculator. You probably would have just typed in, let me look it up. The square root of 50, it happens to be 7.07. So you could have just done 7.07 times, oh, sugar. That was for perimeter. My bad. So what do we say that was? 20 square roots of 2, or you could have typed in 7.07 times 4, 28.28. So that was the perimeter. For the area, all the area is side squared. So I'm just going to make it easy for me and say, well, the square root of 50, because that's easy. The square root of 50 times the square root of 50 gives you the square root of 2,500. And then the square root of 2,500 just happens to be 50. And that's it. All right. So lovies, between this video and the other video, you should be straight for your performance final. What? Okay. Bye. Bye, 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 bye.